Hi, today I want to do a practice problem on projectile motion. So we're going to be talking about two-dimensional motion. We'll deal with the horizontal and the vertical. It's a baseball problem today. So we've got Hank Aaron up to bat. And the problem reads, a baseball leaves the bat of Hank Aaron with a speed of 34 meters per second at an angle of 37 degrees above the horizontal. The ball is 1.2 meters off the ground when it leaves the bat. To be a home run, the ball must clear a fence that's 3 meters high and 106 meters from the batter. So we're going to do this in 3 steps. So let's start where we always start, draw a picture. Okay, so there's my batter. Okay, my wonderful picture. And then the ball's going to leave. It's going to go all the way over. And there's a fence over here somewhere. I'm going to be optimistic and say it clears the fence. So we know it starts 1.2 meters above the ground, and this fence is 3 meters high. And it was 106 meters from the batter. Okay, so that's my basic wonderful picture. We always choose our coordinate system. I'm going to do my standard coordinate system. Up positive, to the right is positive. And I need to pick an origin, so I'm going to say the origin is, I'm going to pick one right here. So that point right there is my 0, 0. So that's my first step. Anytime we solve a problem, draw your picture, do your origin, do your coordinate system. Now we have to figure out what we know, and so we're going to do our chart, but now we have 2 charts, as we've done the last couple times. This time, one chart's for horizontal motion, one's for the vertical motion. So same 6 variables, position, initial, position final, V initial, V final, A and T, and these are all horizontal, horizontal, horizontal. And same thing in vertical. Y initial, Y final, V initial, V final, A and T, and these are all in the Y direction. Okay. So what do we know? Well, anytime we have projectile motion, you automatically know the acceleration. We know there's no acceleration horizontally, and vertically this thing is being controlled by gravity, so we've got our negative 9.8 meters per second squared. So you can always start with those. Out of those 12 variables, you always know those 2. And let's see what else we know. All right, we chose our origin here. So horizontally, the ball is starting at the origin. And vertically, well, I picked my origin at the ground, so our starting point vertically, our starting position, is 1.2 meters up. Is there anything else we know? Well, I'm not sure how I'm going to use these 2. I could say I know this is 106. I could say I know this is 3. But I can't use both of them because I don't know for sure that when the ball is 106 meters over, it is exactly 3 meters up. So I can't say this is 106 and this is 3. I'm going to have to figure out how to do this. Don't know anything about time, initial velocity, and here's where we're going to do the same thing we do for almost every projectile motion problem. We're going to draw a velocity triangle. So we had 34 meters per second at an angle of 37 degrees. Okay. Now this is my initial speed. So it's moving 34 meters per second, but that doesn't go here, it doesn't go here, because it's not moving 34 horizontally and 34 vertically. So we have to figure out what the components are. This is going to be my horizontal component of the initial velocity. Here's my vertical component of initial velocity. This is a trig problem, and this is the same shortcut I'm going to be doing throughout the class, so get used to this one. The horizontal here, VI cosine 37. VIY is going to be the sine component. All right, so we've got those 2. We know VI, we know the angle. Oops, I just had 57. Let's go back to 30. Whoop, whoop, whoop. Let that dry a little. 37. All right. If we calculate that out, we get 27.1 here. And and 20.5 here. Now be careful, these are meters per second. This is not a distance or position triangle. This is meters per second, this is meters per second, this is meters per second. So don't mistake this for something that we can use over here with position. This is just telling us about our speeds. So VIX, now I know this, 27.1 meters per second. And I'm going to say, going to the right, positive. VIY, 20.5 meters per second, and going upwards, I'm assuming. So positive again. All right, so there's our setup. And I talked about those. We don't know anything about V final. We don't know how fast this thing's going over here, and we don't know time. I think we're done for the moment with our setup. So now the first part of the question says, at what times after being hit will it reach the height of the fence? So if we look at what we've got here, the ball is starting 1.2 meters up, and so real quickly it's going to be 3 meters up, and then way over here it's going to be 3 meters up. So we're going to figure out what times we have where the ball is 3 meters off the ground. So that means I want to know time, and these two are equal, and I'm setting my Y final to be 3 meters off the ground. Don't know this. So don't assume you can set this to 106. We're going to figure out what times we've got first. All right, so my times, I want time for my height at 3 meters. How can I get time? Well, I look this and I don't have much information there. I'm not going to try that direction. Well, let's try the vertical direction. I know a lot of stuff here. I know everything but V final Y, and I'm looking for my time. Okay, whenever I don't know V final Y, I go to the long equation, because that doesn't have V final in it. Okay, so we've got my initial position, we know, and final position we know. V initial Y we know. We're looking for time. We know 1/2. We know A. We're looking for time. Okay, we know everything but time in this equation. So we can solve this. It's going to be a quadratic, but hey, we can do quadratics. Y final 3.0 equals 1.2 plus 20.5t plus 1/2 negative 9.8 t squared. So if we combine this down, okay, that's a negative 4.9 t squared. That's plus 20.5 t, and then I'm going to bring that over. It's going to end up being a negative 1.8, looks like, equals 0. Let's double check that. Yeah, okay, so yep, quadratic. Okay, quadratic form, negative b plus or minus the square root of b squared minus 4ac. Don't lose those negatives. They're telling us important stuff, so don't forget to keep track of all your negatives. All over 2 times a. All right, I'm not going to do all the math right here. You have calculators. You can do this part. So what I get for t is, what do I get? 4.1 seconds and 0.088 seconds. And again, make sure they're reasonable. So I have one that's a really long time and one that's a really short time. So less than 1/10 of a second to go from 1.2 meters high to 3 meters high. So you're swinging, it's starting 1.2 meters off the ground, go pretty quickly up to 3 meters. Yeah, I'd say that's reasonable, especially, that's really darn fast. That's 70 miles an hour or something. So I think that one's reasonable. And then 4 seconds, yeah, so here's our 0.088 seconds, and then takes 4.1 seconds to get over here where it's at the same height. So those seem reasonable. Now I want to show you a different way to do that. If you don't like the quadratic, we have a different way we can figure out what the times are. It's a 2-step method, but again, if you don't like the quadratic, you're fine. We have this other way we can do this. So I'm looking for time. I don't know V final Y. Well, maybe I can find V final Y, and that'll get me my time. That's going to be the process we're going to take. So ignoring the fact that I don't know time, can I solve for V final Y? Yeah, I have this equation. The one equation we've got that doesn't have time in it. Okay, so V final, V initial to AY. I'm looking for V final. I know V initial. I know 2. I know my acceleration. I know my change in height. Got it. Okay, so V final squared equals v initial squared, 20.5 squared, plus 2 times my acceleration, negative 9.8, change in y. And change in y is always final minus initial. So final minus initial, 3 minus 1.2 is a positive 1.8. Okay, so here I'm going to get v final squared equals something. What do we get? What do we get? I didn't write it down. Okay, I wrote down that. So what I wrote down was my v final is 19.6. So I took that square root though, because this was a squared, so I had to square root it. Remember, when you take a square root, there are 2 possible roots. So I have a positive and a negative, because if I square both of these, they'd both fit this equation. All right, so which one am I going to use? Well, we got 2 answers for time. So I have 2 possible v finals. I have 2 answers for time. This is going to work. So now I have 2 answers here for v final. Can I get time from this? Well, let's go to the third equation. We're going to use all 3. Here's the long one. Here's the squared one. What's the third one? We've got this one. So I've got v final equals v initial plus at. Now I know my v final. I know my v initial. I know my a. I can solve for t. So my time is going to equal v final minus v initial over my acceleration. And I'm going to have to do this twice because I have a positive 19.6 for v final, and I have a negative 19.6 for v final. So I'm going to get 2 answers. You can go do that math, and you're going to come out with, look at that, 0.088 seconds and 4.1 seconds. You get the same answers. So if you're comfortable with quadratic, you can do it in 1 step with the quadratic. If you don't like the quadratic, or you just want to do it a different way, you can do it in 2 steps where you find v final here, and then once you know v final, you can do this. This has a little bit of a trick you have to remember though, because when you take a square root, you have 2 roots. You have a positive and a negative. And this should make sense because we're figuring out the time at which it's at 3 meters. So when is the baseball at 3 meters? Well, when it's at 3 meters, v final could be a positive 19.6. That would be right here. And if you think about it, this is in the y direction. It's going up. Positive 19.6. So this is still going up. When it gets all the way over here, v final y is a negative 19.6 because it's on its way down. So again, this makes physical sense as well as mathematical sense. So we have our times now. So we know the times at which the ball is at 3 meters high. So I've got 4.1 seconds and 0.088 seconds for my time. So I've got that. Okay, what's next? What am I doing next? Well, okay, we figured out part 1. Part B, part 2, I guess. How far from the batter will the ball be at these times? So we know the times when the ball's 3 meters above the ground. Now we're going to figure out how far away are we horizontally, because if we are more than 106 meters away, we know it's a home run. So let's figure out how far horizontally we are when we're 3 meters above the ground. So that's our next step. Now, if you think about it, we don't have to change our graphs at all. A lot of times with these problems, we've had to redo a graph, or have 2 sets of graphs. One when we might have going to the peak of the motion, one going to for the whole motion. So in this case, we can keep this whole graph. There's nothing we have to change. We're still just going from here to here. This is all good. So now we're looking for the horizontal position. So that's our x final that we're looking for. We've used the vertical position. We know everything. We even figured out that one. We figured out that one. So now we're going to try to fill in that the horizontal chart. Okay, so we knew this was plus or minus 19.6. We have our times. 4.1 seconds, 0.088 seconds. We're going to fill in absolutely everything here. So now we want to figure out what's our final position when we're 3 meters above, which is when we're at these times. Okay, so I'm looking for x final. I don't know v final x. Well, actually, I do. Take a look at that right there. If we have no acceleration, we know that there's no change in speed. So whenever you have this, you know these two have to be the same. Oh, okay, so we could use actually, I think we could use 2 of the 3 equations. Yeah, but if I'm looking for x final, I have an equation for x final. Let's go with that one to start. X initial plus v initial t plus 1/2 a t squared. And now remember, keep these separate. I'm all in the x direction now, so it's all x's all the time. I can't use ay here or viy here. All horizontal. Anything 0? Well, I've got my initial position I set to be 0. My acceleration is 0, so this whole term drops out. Well, this is easy. X final equals v initial x times time. Okay, I know v initial x. I know my time. So I'm going to have 2 answers again, because I have 2 times. So v initial x, 27.1 meters per second times either 4.1 seconds or 0.088 seconds. So what do we get? We're going to get 2 answers, which should make sense, because one's going to be real short horizontal distance, one's going to be a long one. And if we do the math, what do we get? We get one at 2.39 meters. So yeah, real short, hasn't gone very far. And then the other, do we make it? It's 111 meters. Okay, we got it. So is it a home run? Well, when the ball is 3 meters above the ground at the farther time, our horizontal position is 111 meters. So the ball is actually over here. And I have a home run. So we answered our question. We've got everything figured out, and I think we're done with that one. Is it reasonable? Yeah, that's the last step. Did we answer your question? Is it reasonable? Yeah, we're good. We got this one. Nice job.